I'll oh, what happened? Wow, this is horrible. That the flood everywhere. Maybe the roof is leaking or something. Wow, that's kind of scary. Okay, I'll address that. About but let me. Okay, can you hear me? All right. I want to talk about a topic I always want to talk about. I mentioned this already several times, but finally I got a chance to talk about the inheritance. So we talk about inheritance, we talk about mostly single inheritance. And I have been, you kind of heard me, I kind of discourage people using multiple inheritance if you don't have to. So as a C or C++ programmer, this is actually very important because other type of programming languages for multiple inheritance, you don't need to know about this. But as a C++ programmer, you have to. This is something called memory layout. So the difference between C or C++ as a programming language versus other programming language, that it gives you the power for you to have a clear understanding about what the memory, where is the address, where is the content, and the idea of casting is a move around that perception. So you have to manage that. This is what we call memory layout. In other programming language, you typically don't need to worry about that because the runtime system, the compiler, together, they took care of all the issues that you need to worry. But C++, it is not the case that the programmer is responsible for managing all the memory. That's why you have a concept called pointer. Okay, so I'm actually going to talk about this. So we have three concepts. You already know what's single inheritance. For your homework assignment number 3, you actually see that how single inheritance is being used. So today we're going to talk about two different concepts. One is called multiple inheritance. One is called virtual inheritance. And I will show you an example. You will see exactly what it looks like. So, oh, by the way, I actually post a link. I should probably repost this link. This is actually a very nice reference to talk about the memory layout in the C++ object, which is really important for you to understand. In fact, some of this is you already learned those from ecs36b when you look at struct, how the memory is. For example, I just show you the things like that. I mean, for example, this is a particular structure that you use struct, similar, and how do they actually decide where to put each byte of your variable? So such that you will be able to directly or more efficiently manage each part of your memory as a C programmer. But I'm not going to go through that unless we have some question about C++. But let me first tell you, what do I mean by memory layout? Let me use the most simple like block diagram to illustrate. So this is our homework assignment number 3. The class hierarchy, we have a core object, we have a transaction fly, shadow fly, and things like that. So we just look at one pass, look at the left pass, core, person, and shadow person. If I just look at shadow person right now. So this inheritance hierarchy essentially indicate that if you create a shadow person object, essentially you also create person and core, because you have everything. So when I say memory layout, I'm saying that whatever memory is needed to support the person object and the core object need to be included when you actually try to create a shadow person object. So the memory layout looks like this. The memory layout typically looks like this. So you have a one memory. By the way, they're all contiguous together. They must be packed together. And so the shadow person is actually on the bottom of the memory. And there is a region depending on how many bytes you need for that particular object, shadow person. And right on top is person object. Whatever memory needed for person. And then right on top of that is a core. So essentially, when you create a shadow person object, you actually have all three. All right. So when you do casting so what's casting? Casting essentially is changing the data type of a particular object, say from shadow person, you casting into person. So essentially, you let your object, even though it's actually been created as a shadow person, but you can actually cast it as if it is a person object. The reason in C++ we do that, the casting is actually a way for us to control whether this is a virtual function or this is a regular member function. We're going to create that very nice sense of what we call polymorphism. Okay, so in this case, you have a regional core object, you have a regional person object, you regional shadow person object. This is your memory address. So now I'm going to ask everybody in front of me as a C or C++ programmer at this point. I know some of you didn't learn C from your previous course, but just pretend you know C, okay? So if I'm actually giving you the address, if you look at the address of a shadow person object, which address you will be given? Is this the first byte of core object in this picture, the orange box? Or the first byte of the person object, that's the green box, or the first byte of a shadow person object. So when you actually, as a compiler, when you want to create the casting, not casting, memory address, when you say new shadow person object, that means like a malloc, right? So the return is a pointer to this memory layout. Where do you think it should pointing to? Just want you to think about a little bit. You want to say something? Nick? Sure. Okay. The best way to know this is actually write a program to actually print it out. The best way to do it is to write a program, print it out, and then try to casting it and try to print it out. Okay. I might not have time to do it right now, but I can tell you that all three of them is actually pointing to core object. So in single inheritance, very simple. It's always pointing to the core object. Okay, to be honest with you, the reason I said I have to write a program because in around 1992, I wrote a program for C++. It actually pointing to shadow person. It would have been pointing to shadow person. So actually the compiler changed the way. Either way, it's actually working because you have enough knowledge to know what you do. The trick is whenever you do casting, I can still access to every single perspective of this object I want to. And if you think about that, if I'm pointing to the top core for all three cases, core object, person object, shadow object, it doesn't matter because the compiler, if you think about this object is only a core object, when I point to the top, I know it's here. I know it's here because I only care about this. So core object, if you're casting this object to a core object, of course, the memory should be pointing at the first. But think about this, if you're actually casting it as a person object, it's also okay for you to point out here because the compiler knows a person object, regardless whether you are a shadow person become person or original person become a person, you have to have this structure, core and then person. So the compiler, so think about this, C++ as a programmer, you really have to start understanding how compiler is catching up all the information in order for you to access every bit of information about the object. So if it's you're pointing at here at core object, and it's a person object. So I know if I skip the core area, because I know a person inherits from core, so I have that knowledge, I can skip this core and then immediately go to the person object. You know what? Let me write a program. Let me just write a very simple program to actually see how this works. Any question? Do you believe me? I don't have to write a program to convince you. Oh, today is easy. Okay. No, let me actually just tell you, let me give you a more complicated example, because what I'm going to do is related to your homework assignment number 4. So that's why I want you to learn this. By the way, before I move on, any question? Okay, it looks like you believe me, so I'm going to move on. Okay, with multiple inheritance. So this is a case. Regardless how you do testing, regardless where you think you are, the first byte of a shallow person object or core object is always pointing at the first byte of the core. And the compiler will figure out whenever you use it, where is your pointer, where is your data, based on this memory layout. Very simple, with a single inheritance. Okay, so now I'm going to show you your first multiple inheritance program. Okay, so in the multiple inheritance program, I'm going to first show you a program. Just take a look. That I have 4 classes: account, employee, student, and work study. Account, employee, student, work study. So essentially, the inheritance relationship is that because employee need to have an account, so employee is an account, and a student needs an account. It's also an account. So essentially, that's single inheritance. Okay. Account, student, employee. You're good. We're good so far. So now the issue is the work study class. The work study class, for the first time, it actually inherit from both employee and the student. Okay, so syntactically, that's clear about this. Syntactically, this is the way you do multiple inheritance. So you actually put class work study and say public employee, comma, public student. That's it. That means that this new class called work study, they actually inherit both base class. There are 2 base class, which is employee and student. Any question? That's multiple inheritance. Okay, so now I'm going to show you memory layout. But before I show you memory layout, which is a long story, I want to show you the, oh, yes. What? Account is like a core, like anything that's on the top. Yeah. So I'm going to show you 2 pictures. I have 2 options for real to explain what I just showed you. Among these 4 classes. So the top, essentially, when I do multiple inheritance, I inherit from both employee and the student. Let me turn off the light a little bit. Is that better or not? Not good. Okay. Let's see this more clearly. Okay, so the top, you can see that I do multiple inheritance for both employee and student, but each of them have their own copy of account. And the bottom, they actually share the same account. So let me actually tell you the difference from memory or from the content perspective. So the top is saying that I'm doing multiple inheritance, but I have, in fact, 2 account objects in this case. If you think about that, it makes sense, right? I inherit from employee, and from student, and I have an employee's account, I have a student account, I have two accounts. They're separate. I'm actually a work study student, and I actually have two accounts from the university to manage two different things. One is for my work, and one is for my study. So that's one way of doing that. You have two accounts. But the other case, which is another way to look at it, is, well, why do I have two email accounts? I just need one email account that I can use for both my employee work and my hand-in, for example, your Kerberos ID. So I actually have this situation like this. So before we actually determine that, well, what do you think? Which one is actually what you believe before you walk in to today's class about multiple inheritance? Which way do you think multiple inheritance should do? The top or the bottom? Two accounts or one account? You think one? So everybody agree? One? This one? This one should be the way, your perception, right? Okay, let me back up. I believe you, and I believe so too. But first, let me tell you the answer. Multiple inheritance in C++ is the top way. Okay, multiple inheritance is the top. Two account, and the bottom is called virtual inheritance. So that's why in C++ they have two different inheritance concepts. One is called multiple inheritance, one is called virtual inheritance. That's multiple inheritance on the top. This is virtual inheritance. The second, I want to tell you that it's kind of challenging if you think about that. In fact, a programming language really needs to provide both concepts. Because I actually, in some cases, I have a situation, I really want to do multiple inheritance, but with separate instance of my whatever, my really grandparent class or something like that. I really need to have two. I mean, just like I have, you have, I mean, we all have two sets of grandparents. So that in some sense, we have to model that. But in some sense, that does make a lot of sense. But so programming language is trying to say, okay, I should make sure the language itself is expressive enough and such that you can unambiguously implement whatever you really want to model in the real world object you want to do. So the number one level is already that you need to know the tedious about the difference. But number two is when you use it, there is a huge impact on your memory layout. That's what I'm going to tell you about multiple inheritance. In single inheritance, you can see that it's very simple. Whatever you inherit, how many deep, I'm always pointing at the first object. But multiple inheritance is actually to be a problem. So essentially, number one, I should tell you that this is called multiple inheritance. In this case, the code, if you write the code, looks like this. So this is going to be what we call virtual inheritance. So syntactically, virtual inheritance, when you inherit something, you have to add a keyword, virtual. Syntax, look at that in the middle. When you define employee, you have to say public virtual account. Student, you have to say public virtual account. If you do that, when you do multiple inheritance here, then you will only have a one instance of that account. If you do that. And by the way, this is actually the simplest example. I cannot simplify this anymore for virtual inheritance. If you think about it, a more complicated tree structure, it's not just one single diamond shape. It's always like a tree with some kind of what usually, technically, we use this term, acyclic directed graph. If you think about in general graph, this could be really complicated. Okay. Any question about the difference? So at this moment, my objective is to make sure you understand the difference between this one and this one. There is a difference. The difference is how many copies you have about your ancestor. when you go to your grandchildren. Yes, please. Yes, it can do that. Okay, in this case, if you have only one, which is a virtual, one is not virtual, that then the copy of the non-virtual will be there. But the copy of the virtual is going to use that. So we'll see that it's actually a pointer pointing to that. If you have multiple virtual, you have a one base, then essentially all of the virtual is going to share that base. Here, this is the most complicated case. That's actually a question, by the way. If you have two, which is non-virtual, two is non-virtual, and the rest is all virtual, then essentially it's going to share the first base. All this non-virtual, because these two bases are going to have their own, right? And then the rest is going to share the same base. The first base. Okay, the first base, what do I mean by first base? It's actually to be where this one. This is the first one. So if there are two, assuming there are multiple, this one is the it's multiple inherited. This one has a real copy, and this one has five, and the rest of them is actually going with the employee. The first one, that's what I'm saying. By the way, the case we talk about, I have never seen programmer doing anything even remotely close to that kind of complication. It's just too complicated. It's hard to, but yeah. Yeah.
So I was just to clarify, whether the first one virtual or not virtual, all the other virtual ones share with the first one.
Essentially, yes.
So in case you said there's two non-virtual, the rest virtual. But the first one is non-virtual, and try this one. But I like first one virtual, we have 3 bases for it.
Sorry, say that again.
Okay, then let's say that there's a lot of virtual and then two non-virtual. All the virtual.
I see what you're saying.
Those two would have their own.
Yeah, those they will have their own. Because when I specify here, I actually didn't even know whether they're virtual or not. When I specify multiple inheritance, in fact, I don't know whether those are virtual or not. The programmer doesn't necessarily need to know that. It's actually on the parent class, how you actually define your relationship with this. So let me show you the virtual inheritance looks like this. So essentially over here, I'm actually not specifying any word virtual. Only that in the direct child level, you actually specify. Yes, it matters actually. If it's multiple inheritance, it doesn't matter. But it matters a little bit. I will show you why. In single inheritance, definitely we don't have all, right? So it's only multiple inheritance and virtual inheritance. And the virtual inheritance is actually that in the memory layout. Okay. Okay. Any other questions? All great questions. Yes. What? Let me quickly. What? The diamond shape is a virtual inheritance. You only have one copy of the account object. And multiple inheritance is non-virtual. It has 2 copies. That's the big difference. So it means that if you try to update one side of the tree, you actually update the same variable, they share the same account, like your banking, whatever, or they have a separate account. You actually, depending on which way you're using student pass or you're using employee pass, you're actually updating 2 different accounts. That's 2 different accounts versus 1 single account. That's the difference between virtual and non-virtual. Okay. Any other question? All right. So let's actually think about the memory layout. Think about memory layout. So I'm actually going to first show you the multiple inheritance case. So this is multiple inheritance on the top with two different accounts. And then if you think about memory layout, it actually looks like this. So the button is work study. And then I have student and account for student. And then I have employee and account for employee. So my memory layout looks like this one. Okay, that's representing, right? There's 5 objects when I create one single work study account based on multiple inheritance. That's the memory layout that the compiler generates this side. And now the issue is that when you do casting, I ask the same question. When you want to do a memory address pointer to the work study object, where it is. When you want to pointing to the student object, where it is. When you want to put the employee pointer, where it is. And when you want to do work study for the student pass, where it is. And when you want to do the account object for the employee pass, where it is. So the casting in this case is going to be not as simple as the example I showed you in the single inheritance. In single inheritance, every pointer is pointing at the top. But in multiple inheritance, it's going to be different when you do casting. So the casting in multiple inheritance is going to change. Okay, so let's actually take a look at this. So in fact, I should have 5 different pointers. Okay, I have a 5 pointer, if you remember, that pointer to each of the 5 objects on the picture. Remember, just repeat. When you create a work study object, you really actually create 5 objects, those 5 objects over there. When you do virtual inheritance, you create 4 objects. So you have a 4 pointer. So now this 5 pointer, let's actually take a look. If you do work study over here, it's the same, pointing to the first 5 of the account E. And if you do employee of the work study, because you're casting to be an employee, it's actually still here. Okay, because actually employee is here. So the memory layout is always go the first one. Let me see, which one is the first one? The first one is employee, yeah. The first one will be on the top. So it's actually still here. But the thing is that when you actually casting it to a student, you actually try to retrieve your student portion of that is actually moved down to here. So now it's different because let me actually show you some coding example. Over here, I want to show you some code example. So if I create a work study student that's obj_ws, it's an object, right? It's an object that I actually created. So you know that even though when I say that single line, I'm actually getting 5 objects in my memory layout. 5 objects somewhere. And now I'm going to start to do casting. So what do I mean by casting? The first way I cast is cast to be an employee. So how do I do that? I actually put the ampersand, which means that is an address of that object. And I basically casting with a pointer to employee. So that's what I mean casting to be an employee. So I kind of transform that work study student object to be an employee object. So normally in C programmer, you don't need to worry too much about this because casting never change the address of an object. Just single inheritance, you also don't need to worry about that. It's always pointing to the top. In this case, you start to worry because if you're casting that as a employee or you're casting that as a student, it's going to be pointing at two different places. Right? That's some of the syntax I put here. If I have a time at the end of today, I'm going to show some demo. Okay, yes. First 3 line? First 4 line? Okay, sure. So the first line is essentially I declare an object. This way is I'm essentially casting a pointer to another object to a different type. So essentially, what is OBJWS? OBJWS is a pointer to work study, right? So now I'm actually convert that to the employee. I'm actually convert that pointer in perception pointing to work study. Now I'm trying to pointing to employee. So now it's just in the memory layout whether that will change that address, that pointer. So sorry. So that's this one is doing. It's doing a casting. Is it doing a casting? So I change that perception to a different object. So this one is create another object, but this line is just I'm actually assigning that pointer OBJWS to another, just like a pointer. So this is okay for those of you who are unfamiliar with a pointer. This is the work study star. OBJPTR is this type work study star represent this is the data type of pointer. That means OBJ pointer is actually OBJPTR is declared as a pointer to an object with a type work study. That's what that is actually the C syntax. By the way, I actually have a lecture to talk about pointer in greater detail. I'm not going to do it right now. I can either give a lecture in discussion or another lecture, or I can actually show you a pre-recorded video about I'm actually talking about pointer or reference at the level of ecs36b, right? And that's actually, and I cover malloc and free there as well. I can do both. Okay. All right. So before I actually really write a program to see what's going on, I want to show you. So first, let me ask: is this any question about this? So this is just show you where the memory bytes should lay out in your system. And first, you know they're there. The second thing you need to know is what is the impact of casting on the pointer or reference based on this kind of layout. Okay, that's two important things for you to know. First, when you do multiple inheritance, you know you have 5, you know where they are, how they are being laid out in memory, and now the casting is help you to traverse the location, each of the component of that file. And a lot of this is really, I don't know how to better say this. A lot of this design is really depending on the compiler. The compiler at the time when they look at the code, whether they can figure out how to access each part of the memory. The compiler, you have to think about in C++, in fact, almost you have to think about what can compiler do in this case. If you don't do this way, why compiler cannot generate the code? They have to do it this way. It's almost a lot of cases you have to think about what compiler can do. Okay, I mean, as a computer science major, you start to actually you should ask the question every time you look at the programming language design. You have to think about why compiler choose to do it this way. It's not random. It's because there is no other way, essentially. Okay. Okay. So if you have no question, I'm going to show you probably one of the most ugly picture in ecs36b. This picture. So now the memory layout for virtual inheritance is actually going to be pretty bad. You're actually adding 2 virtual pointer in here. So you have a 4 object. Initially we'll think that, okay, great, virtual inheritance, we only have 4, and the multiple inheritance is 5. So you think that virtual inheritance is going to cost less memory because we only have 4 pieces of memory instead of 5 pieces. Not necessarily, because you need to add extra space to actually putting a pointer within the object instance. So the compiler or the runtime support more specifically in this case, because compiler cannot figure out. Let me actually challenge you to think about why compiler has to generate code like this. At the runtime, they can actually figure out when you need to do casting. It's almost the same as a virtual function because compiler lost the knowledge. And it's only until the runtime, they have to use that virtual pointer to actually find out where it is when you want to do casting. So that's actually always the case. That's why I say you have to think about what compiler cannot know in cases like this. So let me actually explain what this looks like. Let me actually show you what the pointer when you do casting, and then we can actually decide what to do. So essentially, when you casting, you see that in this case, regardless how you are casting, you're basically flipped between these 2 positions. If you are the work study pointer, or you are the employee pointer, or you're an account pointer, you're always pointing at the top, account E. It's only when you actually try to access the student part of the work study, you will be shifted over here. So those 5 pointers got grouped into 2 groups, either employee or it's work study. Okay, that's the address over here. So now over here, I have 3 groups. I have 3 groups. And if you want to access really to the account, to the ancestor, it's actually pointing over here. It's pointing here. And then the other thing, which I don't know if you realize that, we flip the order. We flip the order. In multiple inheritance, the ancestor class always go to the upper memory address location. So it's always, by the way, this is the memory address layout. Means that each of this has a memory address, and the order, the way I put it, is exactly how compiler will generate code to put that in the memory in that order. So essentially, account will be in a smaller or higher memory address, depending on what the memory actually grows this way, just like you know the red bar. So the account will be on the top, the first account at least. But anyway, account is always on top of their derived class. It's the same as a core object, person, shadow person. The core is always on the top, and then person, and then shadow person. It's always follow that order. That doesn't change in multiple inheritance. But in virtual inheritance, it flipped. The account is actually at the lowest part, and then on top of that is the work study. So whatever you actually share, you cannot put on the top. You actually put in the button. So essentially what you have is a work study, and then student and the employee. If you look at this part, okay, if you look at this 5 block on top of the account, this 5 block, if you replace this virtual pointer with account, then this 5 block, the memory layout is actually similar to layout here. in terms of their relative order. But because of the virtual inheritance, because I know people are going to share the account, and I actually put the account in the button and make sure that whenever they have the virtual pointer, it's going to pointing to this one. Yes.
For just plain old students, would account get shoved to the bottom as well?
For what?
Or just like student order? Would it be like the account student? Would it be account student or would it be the pointer student?
Well, this is virtual inheritance. In virtual inheritance, they only have one copy of the account. So you see the difference between, if I understand your question, that this picture is actually represent this virtual inheritance. In the virtual inheritance, I only have one copy of account. They both share.
Just for student, like just before we're studying for student.
The student in this case will be, if it's a virtual inheritance,
Yeah.
if I create a student, I know what your question is. I try to think that I never write that code, so I don't know that. I have to do that careful, but my best guess is going to be virtual pointer, student, and account. These three. Yeah, that's my best guess. Okay, now I want to tell you that what that pointer is. This pointer is pointing to the account. So essentially, this one is pointing to a virtual table in your runtime system, and runtime system is going to tell you where to look for this account. So there is an indirection. That virtual pointer is going to pointing to a, that's why it's not virtual pointer, I call it V tables. So in C++ language, there is an area of memory that's actually somewhere in the runtime support. It's actually contain all the pointer, and that pointer is keeping the value about where this one is. So this one will pointing to that table, and then it will point here, and that one also point to the table. And so for you to access account, actually at runtime needs two reference. Reference the table and use that table, then reference. It's almost the same as a virtual function. It's instead of the table of a function pointer, it's a table of where that virtual class I care about. Okay. There was a few. I know that this is the first time to you. It is hard. It's even for very experienced C++ programmer, they're still very confused about this. I actually, to be honest with you, I myself never need to use this type of thing in my doing real programming because I kind of avoid it. But I have actually talked to very pretty senior C++ programmer, and they actually didn't even realize the memory layout looks like this. But if you want to do anything kind of like a memory manipulation, and you don't know the difference between virtual and public, you kind of have some misunderstanding about where your object is, especially when you want to think about this. If you actually think about this, I'm actually assuming the memory layout looks like this. And then I think I just go up, I get access to my account S. No, you actually need to go down in this case to find your account. And you generally, you don't know where that is. You need to rely on virtual pointer because compiler doesn't know this one is. And if you think about asking what the question you asked, you think about that, why I said the account need to be down here when you create a student object. Because I actually don't know whether there is a work study exists. When you have it, I don't know. I just know that virtual relationship between the student, but I don't know where this work study is. So this one is possibly there, but it might not there. This one might be, and maybe the inheritance is more complicated than that. I mean, there are maybe 3 or 4 and multiple layer of this kind of virtual relationship. And it make it really hard for compiler by only look at one reference, say student, decide how many bytes I'm going to move over here. So essentially, this is totally undecidable at a compiler time. I don't know what's the distance between the student object and the account in the virtual setting. Therefore, the compiler cannot decide. So they have to use a virtual table pointer to say at the runtime, when you create an object, I'm going to update that virtual table. Just exactly the same reason why virtual function is decided at the time of creation. I also can only decide the layout until I actually create that object. I know exactly where that is, and I store the information in a virtual table. And so when you do casting, let me actually tell you now the answer to those 5 pointers. If you have a work study object in virtual inheritance, the pointer is pointing at the first byte. That first byte, in fact, is not a data. It's a pointer for you to access the account object. Okay, I think I'm almost here. Sorry about that. And the second group, if your employee is also over there on top, student, when you do casting, you actually need to move over here to the student part. And then you have your account by the virtual pointer. So the memory layout actually looks like this. So I'm actually telling you the concept today. So your homework assignment number 4 is actually using exactly the same example, but ask you to actually spend time to play around the pointer in both virtual inheritance and multiple inheritance. On Wednesday, I'm going to show you a demo about looking at code. But today, I just talk about the concept. I want to make sure the concept is clear, and then we can look into how the syntax of the programming works. Okay, I'm going to stop here.